Hello everyone. Today I am going to talk about thermochemistry. Thermochemistry is the relationship between chemistry and energy. Energy is the ability or capacity to do work. Work is a force acting over a distance. Heat is the flow of energy caused by a temperature difference. There are different forms of energy. We have the kinetic energy, potential energy, thermal and chemical energy. There are various forms and units of energy. Joule and calorie. Joule is the amount of energy needed to move 1 kilogram mass by a distance of 1 meter. Calorie is the energy needed to raise the temperature of 1 gram of water by 1 degree C. 1 calorie equals 4.184 joules. This should not be confused with food calorie, which starts with an uppercase C. 1 food calorie equals to 1,000 cal, which is equal to 4.184 joules. Conservation of energy. The law says that energy cannot be created or destroyed. When we look at this conservation of energy, we're going to be talking about systems and surroundings. A system is a process within which we are studying energy changes. Surrounding is everything else which the system can exchange energy. Basically, what we are studying is the energy between the system and the surrounding. The first law of thermodynamics is the law of conservation of energy. This means that the total amount of energy in the universe is constant. Internal energy is the sum of the kinetic energy and potential energy of all particles that compose the system. The change in internal energy depends only on the amount of energy at the beginning and the end. I want to show us illustration of the exchange of energy between the system and the surrounding. Let's take a look at this first picture here. We have the system, that is a process in which we're studying, and the surrounding, like we said, is everything else. When energy flows out of the system, it goes straight into the surrounding. The change in internal energy for the system becomes negative, while surrounding becomes positive because energy is going into the system. Delta E system is less than 0 or negative, then we say delta E for the surrounding is greater than 0 or positive. The second diagram here shows energy flowing from the surrounding into the system. We can see as energy leaves the surrounding, it becomes negative and the system becomes positive because energy goes into it. In this case, delta E system is greater than 0, which signifies positive, and delta E for the surrounding is less than 0, which is negative. Like we said, the exchange of energy that we're going to be looking about is between the system and the surrounding. The main forms of energy exchange between the system and the surrounding that we look at here is in form of heat and work. Heat is denoted with the lead symbol Q, while our work is denoted with the symbol W. And because of what we talked about, internal energy is the sum of all the potential kinetic energy. So the change in internal energy, that's a E, is going to be equal to Q plus W, which we have here. Q is positive when the system gains energy. When the system loses heat, Q becomes negative. When work is done on the system, W becomes positive. When work is done by the system, W becomes negative. When we add these together, it means that when we have positive Q and positive W, delta E, which is change in internal energy, becomes positive. This implies that energy flows into the system. When energy flows out of the system, our delta E becomes negative. Example: if the burning of potato engine performs 960 joules of work on a potato and produces 1140 joules of heat, what is internal energy for the burning fuel? The first thing we should do here is to write our relationship, which is delta E equals to Q plus W. In this case, our Q is given as 1140 joules. Because the heat is produced, our Q becomes negative. 950 joules of work is done. 960 joules of work is done for W. Because our W, the engine performs work, our W equals negative 960. 960 joules. Therefore, our change in internal energy is going to be negative 1140 plus negative 960 joules, which gives us negative 2100 joules. We have pressure volume work, which is a product of pressure times change in volume. PV work is caused by volume change against external pressure. When gases expand, delta V, change in volume, is positive, but the system is doing the work. So the surrounding is negative. The W, the work done by expansion gas, becomes negative. So we have W gas, work done by the expansion gas, negative P dV. We have to remember that the change in volume is V final minus the V initial. Example: To inflate a balloon, you must do pressure work on the surroundings. A balloon was inflated from volume of zero point 0.1 to 1.85 liter against external pressure of 1 atmosphere. How much work is done on the system? So, because we have a volume change which is from zero point 0.1 to 1.85. This gives us an idea that this is going to be an expansion work done. So our dV change in volume becomes 1.85 minus zero point 0.1 liter, which gives us 1.75 liter. So, because this is an expansion work done, our W get is gonna be negative P dV, which is our one atmosphere. Our pressure is 1 atmosphere. Given you have negative 1 times 1.75 liter. This is atmosphere pressure. Mm, 1 atmosphere times 1.75 liter. This gives us negative 1.75 liter atmosphere. So remember, our work has to be in joules. So we convert this to joules. Given this relationship, we have negative 1.75 liter atmosphere times, which is our desire, which is our joules, 1013 joules over 1 liter atmosphere. So we have this to be negative 1.75 joules. Sorry, negative 177 joules. Another example, calculate the change in internal energy for a system giving off heat and is changing from 12 liter to 6 liters in volume at 1.5 atmosphere pressure. So the first thing we do is to write our relationship, which is delta E equals Q plus W. In this case, our Q is 15 kilojoule. It's giving off 15 kilojoule. Okay. Because heat is given off at 15 kilojoule, our Q is negative. Then our work is P times the V, and our work is negative P the V. So we have our pressure to be 1.5 atmosphere times change in volume. Our final volume is 6 and the initial was 12. So this gives us negative 1.5 times negative 6. And that gives us 9-liter atmosphere. We convert this to joules. This gives us 911.7 joules. Remember, our delta E is going to be negative 15 kilojoules plus, we convert this to kilojoules, it's going to be plus 0.9117 kilojoules. And this gives us negative 24.089 kilojoules. I hope this helps to help us practice our examples and as we solve more problems. Thank you for watching.